Okay, this is the first lesson in pre-calculus, and we're going to be reviewing factoring. The first type of factoring that we're going to review is the difference of two squareds. Now, difference of two squareds are always in the form a squared minus b squared, and they always factor down into a and b, and the factorization is a plus b times a minus b every time. So let's look at x squared minus 9. That's x and x. And 9, the square root of 9 is 3 and 3. So it factors into x plus 3 and x minus 3. 4x squared minus 25. That's 2x times 2x. And 5 times 5. So it factors into 2x plus 5 and 2x minus 5. X to the fourth minus 16. X to the fourth is x squared times x squared. 16 is 4 times 4. So it's x squared plus 4 and x squared minus 4. But if you look at x squared minus 4, that's a difference of two squareds too. That one factors into x and 2 and 2, which is x plus 2 and x minus 2. Now, if you look at the plus, it cannot keep going. There is no sum of two squares rule, so you just bring it straight down. The next type is the trinomials. Now, there's the shortcut for trinomials. I'm going to do it both ways, but the shortcut only works if you have no number in front of your x. It doesn't work if you have a 3, so I just don't do it ever. I recommend that you just don't do it. So the long way to do this is a little, I call it an S and P chart. The S stands for sum, and the P stands for product. The sum is always your middle term, so you'll come here. The middle term is 4x. The product is the first term multiplied by the last term, so 4x squared. Product stands for multiply, sum stands for add. So you want to know what multiplies to give you 4x squared and adds to give you 4x. Well, 1 times 4, 2 times 2, so it would be 2x times 2x is 4x squared. 2x plus 2x is 4x. So what I do is I replace the 4x with 2x plus 2x. So I bring the first one down, replace the middle with 2x plus 2x, and then bring down the plus 4. And then I group. And then I look and I say, alright, well, what's common to the first two? What can I take out of x squared and 2x? Well, I can take an x. And then I divide. I say, well, I had two x's.
Teachers, please pardon this interruption at this time. If anyone needs to return their textbooks, please send them to the book room.
I have two x's. If I take out one, I have one left. And then I check it back and I say, well, does x times x give me x squared? And it does. Plus, I had 2x. I took the x away, so all that's left is 2. I bring down my sign, whatever it is, it comes straight down. If it's a minus, it comes down. If it's a plus, it comes down. And then I look at my next two and I say, well, what can I divide out of these two? What's common? Well, will 2 go into 4? And it will, so I take out a 2. And then 2x divided by 2 is x. And 4 divided by 2 is 2. Every single time, what's in these two parentheses should be the same. And then what's left, not underlined in purple, is in the other set of parentheses. So, do one more. Like that. 5x, and then first times the last, 6x squared. What multiplies to give you 6 and adds to give you 5? 3 times 2 is 6. 3 plus 2 is 5. So I replace the middle with 3x plus 2x. So I bring down the first one, plus 3x plus 2x, and I bring down the plus 6. And then I group. And I say, well, what can I take out of x squared plus 3x? What's the same in both places? Well, an x. So I take it out. I had x squared, I take out an x, I have x, plus, I had 3x, I bring an x out, I would have a 3, plus, I bring down my sign. What can I take out of these? I can take a 2, and it'll be x plus 6 divided by 2 is 3, because remember factoring is division. And then I say x plus 3, and then what's left not underlined in pink is x plus 2. The shortcut, of course, you probably know how to do the shortcut, is whatever you get here ends up being your answers, positive 3, positive 2. So this one, negative 9 and 20, what multiplies to give you 20 and adds to give you negative 9? Well, negative 4 times negative 5, so it ends up being x minus 4 and x minus 5. Now that only works on the ones that don't have a number in front. The ones that have a number, you have to work them out. So let's work it all the way out the same way. My s is my middle number, my middle term, negative 20x. My product is my first multiplied by my last. 3 times 12 is 36x squared. What multiplies to give you 36 and adds to give you negative 20? 18 and 2 is 36, but it'd have to be negative 18 and negative 2, so negative 18x minus 2x. So I bring down my first one, minus 18x minus 2x, and then I bring down the plus 12, and I group. What can I take out of the first two? Well, 3 actually goes into 18, so it would be 3, and both of them have an x, so 3x, and then x minus 3 goes into 18 6 times. Bring down the sign, minus. I can take out a 2. 2 goes into 2x, x, and negative 2 goes into positive 12, negative 6 times. Notice these are the same. And then 3x minus 2. Okay, let's do one more. Negative 13x, and then 2 times negative 45 is negative 90. Multiplies to give me negative 90, adds to give me negative 13. If you're not sure, you can kind of cheat just a tiny bit. Let me show you how. If the number gets big, if you'll go to your y equals and type in your number, negative 90, divided by x, and hit second table, and just scroll, and there's all the numbers, the ones that aren't decimals. 1 times 90, 2 times 45, 3 times 30, 5 and 18, 6 and negative 15, 9 and 10, 10 and 9. When they start repeating like that, that's it. And if you notice, it was negative 18 and 5, give us negative 13. So it would be 2x squared, bring down the first one, replace the middle, negative 18x plus 5x, bring down the minus 45, and then I group. I can take a 2 out, and an x, and it'd be x minus 9, and then plus, 5 goes into 45, so I can take a 5, x minus 9, so it's x minus 9, and 2x plus 5. That's what's left. Okay. And then the third method of factoring is by grouping, and we've actually already been doing that. You just group the first two and group the last two and say, okay, what can I take out of the first two? Well, I can take an x squared out. I had x cubed, I took 2 of them away, so I have 1 minus. I had 2x squared, I took the x squared out, so I'd have 2, plus, I take a 3, and then x minus 2. So it would be x minus 2, and x squared plus 3. I can take out an x squared plus 1, if I group the first two, group the last two, plus I can take out a 2, x squared plus 1. So it would be x squared plus 1 and x plus 2. The next thing we want to look at is solving systems. The first method to solve systems is by graphing. You just want to graph it and see where they cross. So I should have gave us graph paper here, but I did not. Darn. So we'll graph it on our calculator. So if we take 3x minus 2y equals negative 6, in our calculator it has to be solved for y, so we're going to put it in y equals mx plus b. So we solve for y. I bring down my negative 2y, and I would have negative 3x minus 6. How do you get rid of times negative 2? You divide all the way across. So y would equal 3 halves x plus 3. And then this one, if we solve it for you'd have negative x minus 2. And then that's already solved. So I'm going to type them in my calculator. And we're going to find an intersection. I'm going to go to y equals I'm going to type them in. 3 halves x plus 3 and negative x minus 2, and I hit graph. We should have graphed these by hand. Second trace, I go down to number 5, intersect 5. First curve, I just hit enter. Second curve, I just hit enter. Guess, I just hit enter, and it tells me when it gets to the point where it says intersection, that's where they cross, that's the answer. So it's negative 2, 0. Now the elimination method, if sometimes is also called the addition method. If you remember from Algebra 2, you want to add down and make something cancel. So I look at it and I say, well, if I add it right now, nothing cancels out. 2 plus 5 is 7, negative 3 plus 6 is not 0. But is there a number that I can multiply one or both of them by to make something cancel? I look at my y's and I say, that one's negative, that one's positive. 3 goes into 6 2 times. So if I multiply the top by 2, and I just bring it down here, 2 times 2 is 4x, 2 times negative 3 is negative 6y, 2 times negative 21 is negative 42, and then I add these two equations. 4 plus 5 is 9. The 6y's cancel, and 15 minus 42 is, I don't know, I think it's negative 27. Better check that. 15 minus 42. Yeah. And then I divide by 9. I get x equals negative 3. Now, once you've solved for one of the variables, you can stick it back into either one of your first equations where the x is. I like this one better because it doesn't have negatives. So I do, I'm writing with a highlighter. I do 5 times x, but x is negative 3, plus 6y equals 15, and then I solve for y. So negative 15 plus 6y equals 15. I add 15. 6y equals 30. I divide by 6. Y equals 5. So my answer is x comma y, so it's negative 3 comma 5. And I know I'm going through these kind of quickly because this is all review from Algebra 2. Then if you need more help or more supplementary materials for any of this, please let me know. It says solve using the substitution method. Substitution method just means you take one of the equations and substitute it into the other one. So what I've got is x equals 7y plus 3. It's already solved for x. What I do is I take that and I stick it into the other equation where the x is. So I do 2 times x, but x is 7y plus 3 minus y equals negative 7. Now if you want to see if we can see that x here, and then just the rest of the equation here. Okay, so it would be, if you multiply it out, 2 times 7y is 14y, 2 times 3 is 6, minus y equals negative 7. We combine our like terms. We have a 14 and a negative 1, which would be a 13. Then we solve. Negative 13, I divide by 13, and y equals negative 1. Then, I've got y, but I need x. Well, do I have an equation somewhere for x? I do. It's right there. So x equals 7y, but what's y? Y is negative 1 plus 3. So x equals negative 7 plus 3. So x equals negative 4. So it would be negative 4, comma, negative 1, because that's x, comma, y. Okay, now this one says solve using any method. This is it, I think, yeah. Solve using any method. So I look at them and I say, well, would it be easier to use substitution or would it be easier to add down? We could either solve the first one for x or y, or we could multiply. I think I would rather, I almost always like the addition method if they're lined up. I say we multiply the top by 2 because 1 goes into negative 2 2 times. So if I multiply by 2, 2 times x is 2x, 2 times y is 2y equals 4. I'm just going to bring the other one over and add straight down. 2 plus 3 is 5x, the y's cancel, equals 11 divided by 5. X equals 2.5. Maybe. My simple math is not the best yet. Nope, 2.2. I was wrong. 2.2. Then I take my x and I plug it back in right there where the x is. 2.2 plus y equals 4. And you're probably wondering, why did I pick that equation? Because it looked easier. The numbers are smaller. That's the only reason. You can pick it. You can plug it into either one. It doesn't matter which one. 4 minus 2.2, 1.8. I don't trust my decimal skills here. And then this one, I look at it and I say, hey, if I add down right now, this stuff's going to cancel. So I'm just going to go ahead and do it. 3x take away 3x is 0. Those cancel. Now, is this a true statement? Does 0 equal 18? No, it doesn't. So what happens is it's no solution. If you were to graph these two lines, they would be parallel. They never cross because they have the same slope. So that concludes that lesson. The end.